So you need to label your x and your y. So to say y and x. Now, first things first, you need to know your equations of the asymptotes. Remember, we did do this one to say x is equal to 3, y is minus 2. Those were the asymptotes here. If you still remember, these were the asymptotes. Alright, these are the equations of the asymptotes. So now x is equal to what? X is equal to 3, y is equal to minus 2. So I can come here on this graph and say x is equal to, let's use that as 3. Can use that line. So here it will be then you take a pen and just erase a bit here, because the asymptotes, you can do it like this. It's an asymptote. You can do it as a shaded line. You know what I mean? So what we have, this is x, this is 3, and then I go to minus 2, I do the other one there. These are the asymptotes. Alright, so you do that to be my dotted lines. Alright, so this is minus 2. Hello, our most devoted student. My name is Confident and welcome to our revision session. This is the exam preparation for grade 11s, and we are looking at one of the papers that was written in November 2019, and this is paper 1, and we are now looking at question number 5. So this is the paper that I've been going through, and I'm preparing you guys for your final exams. Remember, the 24-minute lesson is designed with you in mind, to prepare you for your final exam, and I want you to smile the day you receive your report card to say, I made it. Now look guys, grade 11 is a very, very important foundation. Remember, you use your November results to apply for university, so you mustn't take it lightly. Now subscribe right now and ensure the notification bell is turned on so that you're notified every time there's a new video. This will help you to always be on time. Every time there's a new video, I'm going to post it. So what have I done? I have done question 1 here. There's a video for question 1, a separate video for question 2. There is also a separate video for question number 3 as well as question number 4, which was on number patterns. So now I'm looking at question number 5, and this one is on what? This question is on graphs. So as I said, ensure that you are subscribed so that it's easy for you to keep following up on this channel. Now look at question number 5. Says you are given f of x is equal to 1 over x minus 3 minus 2x plus 6 over x plus 3. And then 5.1, show that f of x can be written as that. So what am I given here? I'm given like this, to say f of x is equal to 1 over x minus 3 minus 2x plus 6 over x plus 3. But now I think already you can see that whenever you are given this part here, let me just bring it here. Look at this 2x plus 6. You can see that you can factorize this part. You can take out 2. So this can be 1 over x minus 3 minus, so you can take out 2 on top. Now 2 into x, 2x, it's x. 2 into 6 is 3. So I factorize that, because if I multiply 2 times x, I get 2x. If I multiply 2 times 3, I get 6. You're getting that? So that's what I'm having, over x plus 3. That's where the trick was. Cancel that. So you get a 1, 1. So it's 2 over 1. This is 1 over x minus 3 minus 2 over 1, which is minus 2. And that's what they are saying here, to say show that this becomes 1 over this minus that. Alright, not complicated per se, but very important. Number 5.2, write down the equations of the asymptotes of f. How many marks? 2 marks. You need to know that. Remember, whenever you are given this equation, let me just go back to the general equation to say f of x is equal to a over x plus p plus q. Now they'll always tell you that if you are looking at asymptotes, you say x plus p, you equate that to 0, therefore x is equal to minus p. That's the equation of the x asymptote. And then the one y is equal to q is the equation of the y asymptote. So same thing here. What you have, you are going to say x minus 3, you equate it to 0, therefore x is equal to 3. That's the x asymptote. And then y is equal to minus 2. Those are the equations of the x and the y asymptote. So it says write down the equation of the asymptotes of f. So the equation is x is equal to 3, y is equal to minus 2. And then 5.3, it says here, determine the x-intercept. So when they say x-intercept, remember x-intercept, you must know y is equal to 0. And then the second question, y-intercept, you must know x is equal to 0. So whenever they say x-intercept, y is equal to 0. So let's start with the x-intercept. That's 5.3. So let me do it here to say, if they're saying 5.3 and they're saying I must find the x-intercept, remember y is equal to 0. But what is y? Y is same as f of x. So you take your f of x, which is that one. Let me just not write it. Already I'm given that. I'm just going to duplicate that. This is my f of x. Yeah. That's my f of x. Right. So this will become what? F of x, remember, equal to 0. So I'll say 0 is equal to 1 over x minus 3 minus 2. Then it's a matter of solving this. So first thing first, take minus 2, let it jump the equal sign. Now look, it's negative. When it jumps the equal sign, it will become positive. So what you have got now 2 is equal to 1 over x minus 3. Now it's up to you what you want to do here, but there is a quicker one. It's 2 over 1. Since it's a fraction on the left hand side, fraction on the right hand side, I can actually invert this, take 1 to the top, take 2 to the bottom. What will I have? I will have 1 over 2 is equal to, what you do on the left, you do on the right. Take that to the top, take that to the bottom. So I will have what? X minus 3 over 1. This becomes much better. But anything over 1 is simple x minus 3. So I've got 1 over 2 is equal to x minus 3. I think that. Now, almost done. Look at this one. We have got minus 3 here. Take minus 3 to jump the equal sign. It's negative. It will become positive. So what we have? I will have 1 over 2 plus 3 is equal to x. There is the x. So which is 1 over 2 plus 3 is 3.5. You can use a calculator. Just use a calculator. So the answer, what is x? Therefore, you can say x is equal to 3,5, or you can write it as 3 times 2, 6, which is 7 over 2, or you can write it as 3.5. It's up to you how you want to write it. But that is what the question was write the determine the x-intercept. So the x-intercept is this one. X is equal to that, but you can write it in coordinate form to say when x is 3,5, y is 0. This is the x-intercept. These are the coordinates. Similarly, we come back here. That was question 5.4. It wants us to find the y-intercept. As I said, you just have to repeat it to say, if this is my f of x here, let me take it again to say this is my f of x. This is 5.4, right? So let me use the space. So it's 5.4. So this is my f of x. So now I'm looking at what? At the y-intercept. So you must know here that the y-intercept, the moment you use the word intercept, you must say y-intercept x is equal to 0. So what you do is you say f of 0, where there is x, remember you put a 0, is equal to 1 over 0 minus 3, because wherever there is an x I put a 0, minus 2. So which is equal to, you can just use a calculator sometimes, you don't have to stress and start wanna use your mental and everything. The calculator just simplifies things. So you have got 1 over 0 minus 3 and then minus 2. It will give you the answer, minus 7 over 3. Then if you want to write it in coordinate form, remember it's an intercept. It's x is 0, y is negative 7 over 3. That is that. And then continue. 5.5, sketch the graph of f showing clearly all the intercepts with the axes and the asymptotes. 3 marks now. We need to sketch this and you get 3 marks. It's not complicated again to sketch that. What you need is to have your Cartesian plane like that. So you need to label your x and your y. So to say y and x. Now first things first, you need to know your equations of the asymptotes. Remember we did do this one to say x is equal to 3, y is minus 2. Those were the asymptotes here. If you still remember, these were the asymptotes. Alright, these are the equations of the asymptotes. So now x is equal to what? X is equal to 3, y is equal to minus 2. So I can come here on this graph and say x is equal to, let's use that as 3. Can use that line. So here it will be then you take a pen and just erase a bit here, because the asymptotes, you can do it like this. It's an asymptote. You can do it as a shaded line, you know what I mean? So what we have, this is x, this is 3, and then I go to minus 2, I do the other one there. These are the asymptotes. Alright, so you do that. It will be my dotted lines. Alright, so this is minus 2. Okay, so what you do is, these are the asymptotes, and then they told you intercepts. We say the first one is the x-intercept. Where is that? This one, x-intercept, and the coordinates of the x-intercept, 3,5 is to 0. X-intercept, where it cuts the x-axis when x is 3,5. So if this is 1, this is 2, that is 3, and that will be 4. So somewhere here we have got 3,5. Are you getting that? So that is very important. And remember, the graph will never cut the asymptotes. So it's more like you have got a graph like this, See, so I know you are saying, but it can't do that. Yes, it can't just do like curve in and out, so it must start just in nicely like this. But anyway, you must do a better graph like that. Unfortunately, I'm failing to hold my pen properly. Now that's the first graph. You need to know, actually, by the way, let me quickly remind you, whenever you are drawing these graphs, let me quickly remind you, if I'm drawing these two graphs like this, I'll erase this. So remember, we said y is equal to, this is a hyperbola. This is a hyperbola. This is a over x. Let's just use that, a over x. If a is greater than 0, is in quadrant 1 and quadrant 3. That's the graph 1 and 3. But if it's a is negative, less than 0, so it's in quadrant 2 and quadrant 4. 2 and 4. So you need to know the shape of the graph. So you can see that a here from the question was positive. See, a was 1, so it was positive, hence the graph is in this part. And then the other quadrant, you can see the graph, there is the x and y intercept. Now it crosses at minus 7 over 3. So what is that minus 7 over 3? You can actually look at it as an estimate to say it is negative 7 over 3. It's what? Press ST there. I say negative 2,33. So it's negative 2,33. So it's somewhere here. Maybe say we can have negative 2,3. So again, it's just a graph that you need to be sensitive in drawing. Kind of like this is much better for me. You know what I mean? So this is the graph. It's in first and third quadrant, and then you can label it, say this graph is the graph of f. Okay, so that's what the part to say what? Sketch the graph, show clearly all. Now let's look at this. If we answered it, then all what? All the intercepts with the axis. Let's go and see where it is cutting the x-axis in this graph. I did show it here, see, and I did show it here. That minus 2,3 and minus 3,5. That is what, so you must write it clear, minus 2,3 and then 3,5. That those numbers, or you can, yeah, they must be visible. Just make sure they are visible. So showing clearly that, and the asymptotes. So you come here, you need to show the asymptotes. So in here you say x is equal to 3, y is equal to minus 2. Just label the asymptotes in as much as you are showing that is 3 and minus 2, but you need to label that. So that's how you get all your 3 marks. Okay, now 5.6, determine the equation of the axis of symmetry of f having a positive gradient. Determine what? The equation of the axis of symmetry of f. Now you need to know something about the equation of the axis of symmetry. What is the key is this one, that point. Let me just do something bigger here. The most important thing is that point. All right, I can even use a different marker to say here. Always know that is the axis of symmetry. So the axis of symmetry can be this version, whereby that line can be like this. It's not yet much straight, or it can be like this. It can be like this, but it's not really that. But now they are looking for the equation. They are saying what? They're saying determine the equation of the axis of symmetry of f having a positive gradient. So which one has got a positive gradient? It is this one. It is this one. If I can show you this one, there's a positive gradient. That one. So if it's got a positive gradient, the key thing again, I repeat, is that point. What is that coordinate? Remember, x is equal to 3, and y is minus 2. Those coordinates are very, very important. So you call that, you take those coordinates to say you have got coordinates x is equal to 3, y is minus 2, and now always know the gradient of this line. M is always minus 1 of a hyperbola. So m is equal to 1. There is minus 1 and 1. So this one is 1. M is equal to 1, and for this one it's m is equal to minus 1. So since they said positive gradient is 1, so you now use the formula y is equal to mx plus c. So y, what is my y? This is y and this is x. So I've got negative 2 is equal to m, which is 1, x is 3 plus c. Now take minus 2 is equal to 3 plus c. Take 3 to join 2. It was positive, becomes negative. Minus 2 minus 3 equal to c. So negative 5 is equal to c. Minus 2 minus 3, use a calculator, get negative 5. Then the equation is y is equal to 1x, which is mx. Remember, y is mx, m is 1, x plus c, but c is negative 5, so minus 5. Then the answer is that. That's the equation that they wanted here. When they say the equation of the axis of symmetry, if they wanted the other one, you're going to do the opposite now. So you can see that this equation, y is mx plus c, it will cut here at minus 5, you see. Had they wanted the one with a negative gradient, you're going to do the opposite. To say m is equal to minus 1, the points are 3 and negative 2. So you're going to say y is equal to mx plus c. Y is negative 2 is equal to m is negative 1. X is 3 plus c. Now minus going there becomes positive. Minus 2 plus 3 was equal to c. So c was going to be 1 is equal to c. So the equation of a line here was going to be y is equal to minus 1x plus 1, this one. If it was that, then you come here and say that point here was going to be 1, and then this one is minus 5. So that is that, but I'm showing you the one that they wanted. The answer they wanted is this one, to say y is equal to 1x minus 5. Okay, from this one. So this is the answer. This one, no, they said positive gradient. Okay, next one. The graph of f is transformed. I like that. The graph of f is transformed to obtain the graph of h, in which h of x is 1 over x. Describe the transformation from f to h. Let's just do it here. So what is the graph of f? Remember, f of x is equal to, let's take it there. It was 1 over x minus 3 minus 2. So it's 1 over x minus 3 minus 2. First things first. You see, I'm going to move it first to say, how can I get rid of this 3? You're going to say, let me erase, make it this long. If I want to move is transformation, to remove that 3, I'm going to move 3 units to the left. Why? Look at this. Where is the graph that I drew? Let me try to look at the graph that I drew. Okay, there is the graph. If remember this graph of let me erase here. They are saying, I'm just gonna make it a point like this. I don't know, it was h of x. They are saying it's 1 over x. If I'm to draw that graph, it would be like this, right? It would be simple, the graph like that. So meaning I have taken this graph here, this one. Yes, I'm going to take this graph, and this graph I want to move it, sorry, that is broken. I want to move it first horizontally. Look, I have to move it 3 steps, so it will go back there 3 steps. You see what is happening? Because it's at 3. So for me to go, it will go to 2, it will go to 1, it will go to 0. So when it goes there, it's 3 steps horizontally. That's the first thing I'm going to do, so that it becomes at that stage there. See? So then at the same time, I need to move these 2 graphs up. See? When it moves up, how many units? 2 units up. So how am I going to write this? So this is what I'm going to do. This is what I'm going to do. So you move 3 units to the left, and then you'll have what? If you move 3 units to the left, you'll have 1 over x minus 2. And then from there, you continue, and then you say move 2 units up. Take it up, so it's minus 2, it must go up, and then you're going to have h of x as 1 over x. So which one is the answer? These are the answers. Move 3 units to the left, and then move 2 units up. Alright, that's how they wanted the answers, 2 marks. And then they say 5.8 says what? Write down the domain of h. Remember, h of x is equal to 1 over x, and the domain are the x values. Domain means x, range means y values. So the domain, one thing is there is a value that is undefined. Remember the asymptote of this graph. If you look at that, if I draw this graph again like this graph is like this graph is like this, it will never touch 0. The asymptote is x is equal to 0, and then y equal to 0. So now this graph, even if you take a calculator and you ask yourself to say what number is it that this graph becomes undefined, if you say 1 over 0, see, it's an error. So here you can say the domain x is an element of real numbers, but x cannot be equal to 0. Or some that write it like this: x is an element of, you can say, infinity. It's negative infinity to positive infinity. You understand? X is an element of negative infinity to positive infinity, but there is a condition: x cannot be equal to 0. That can be either this or that, they will still be fine. Those 2 conditions will give you the domain. Alright, let's say what if they wanted the range? I'm just going ahead of myself. Now for the range, you're going to say y is an element. You look at this. The y values, again, they can increase, but up to that they cannot be 0. So y is an element of real numbers, but y cannot be equal to 0 also. That's that graph also. Similarly, the x and the y. Guys, we've come to the end of our lesson here. We're looking at the graphs. Now the next section will be question 6. Again is the graphs, as you can see, but this one is the parabola part. Join me again when I'm going to be focusing on this. It's 19 marks also, but you cannot afford to lose them. We've come to the end of our lesson. Remember to subscribe and ensure that the notification bell is turned on so that you're notified every time I put a new video. Thank you.